Hello students, now today we will discuss equilibrium constant from Nernst equation. How we can calculate this we will understood. Now we are taking example of Daniel cell. Now in Daniel cell following reaction occurs. That zinc is working as a anode and copper is working as a cathode. Now when cell reaction occurs, it is observed that zinc will start to convert in a Zn plus 2. So it is observed that in solution of electrolyte, concentration of Zn plus 2 will slowly increase. Now similarly, copper plus 2 ion present in a solution is start to convert in a copper solid. So we can write that concentration of copper plus 2 ion in solution will decrease. So it is observed that slowly cell potential is going to decrease. So we can write that when cell reaction occur, it is observed that cell potential is start to slowly decrease. Now one time will come. At that time now there is a no change in a concentration of Zn plus 2 ion as well as change in a concentration of copper plus 2 ion, and this state is known as a equilibrium state. So we can write that at equilibrium state, when system will attain equilibrium, so at equilibrium state no change in a concentration of ion. Now there is no change in concentration of Zn plus 2 ion as well as there is no change in a concentration of copper plus 2 ion, and you will observe that slowly in galvanic cell, galvanometer indicate potential of the cell, this will be a 0. So it is observed that when system attain equilibrium, the potential of the cell, E cell, will be 0. So now first for this reaction we can write Nernst equation in this way. Nernst equation we can write for this cell reactions that E cell equal to E0 cell minus 0.0592 upon N into log concentration of product means concentration of Zn plus 2 and concentration of reactant means it is a concentration of copper plus 2. Now when system attain equilibrium, there is a no change in a concentration. So we can write that concentration of Zn plus 2 upon concentration of Zn plus 2 upon concentration of copper plus 2. We can write a equilibrium constant, it will be a Kc. So now put value at equilibrium state, cell potential will be 0 and this will be a equilibrium constant. So we can write in this way 0 equal to E0 cell minus 0.0592 upon N into log Kc. So now this will go in opposite side. So we can write that cell potential means standard cell potential E cell equal to 0.0592 upon N into log Kc. So by using this equations, or we can write in this way also, suppose 0.0592 not return, then we can write that original form, we can write in this way also that it is RT upon NF. R equal to gas constant, T equal to temperature in Kelvin, F Faraday constant, N is change in electron, and equilibrium constant log Kc. So by using this equation one can calculate what is the equilibrium constant for any electrochemical cell. So it is observed that when equilibrium established, there is a no change in a concentration of ion associated with the cell reaction, and therefore potential of the cell become 0. Now this we will understood with help of one example. We have to calculate what is the equilibrium constant for these cell reactions. Here we have given this cell reaction that copper reacting with the silver ion. Copper is converting in copper plus 2 ion and silver ion is converting in a silver. Now cell potential is 0.46 volt, then what is the equilibrium constant? This we have to find out. So we will use the same equation that E cell, standard cell potential E cell equal to we can write directly 0.0592 upon n into log Kc. Now I have to find out what is the equilibrium constant, so just I have to put value in this equation. Standard cell potential is 0.46 equal to 0.0592 upon n. Now n is change in electron. For this cell reaction, change in electron is 2. Copper is losing 2 electron and 2 silver ion gaining this 2 electron. So divided by 2 equal to log Kc. So we can simplify this log Kc equal to 0.46 and divided by, now 0.0592 divided by 2, so you will get 0.0296 and this 0.0296 will go in denominator, so we can divide by using this 0.0296. Now simplify these things. So by simplification of this you will get 15 point, just you simplify by yourself, you will get 15.6. So now simplification you have obtained 15.6. So now to find the equilibrium constant, Kc is nothing but an anti-log of 15.6. Now in anti-log there is a system. Suppose आपको देखना है 0.6 का anti-log 0 में और 15 है point के पहले वो 10 की पावर में चला जाएगा. So we can write directly 10 to the power 15. अब anti-log देखेंगे then you will get 3981. तो 0.6 का 0 में जब आप एंटी लॉग लेते हो तो 4 डिजिट मिलेगा 3981. फर्स्ट पॉइंट के आफ्टर पुट है पॉइंट, सो 3981 मल्टीप्लाई 10 टू द पावर 15. सो इक्विलिब्रियम कांस्टेंट फॉर दिस सेल इज 3981 into 10 to the power 15. सो यदि आप सेल के स्टैंडर्ड पोटेंशियल पता है then you can find what is the value of equilibrium constant. Suppose यदि हम डेनियल सेल की इक्विलिब्रियम कांस्टेंट निकालना चाहते हैं then we can find out कि भाई सेल पोटेंशियल, स्टैंडर्ड सेल पोटेंशियल फॉर डेनियल सेल इज 1.1 वोल्ट. तो डेनियल सेल की स्टैंडर्ड पोटेंशियल 1.1 वोल्ट है जो हमने अभी सेल रिएक्शन लिखी थी. तो ये डेनियल सेल है जिंक Zn+2 सेल रिएक्शन, सेल इज वर्किंग इन ए स्टैंडर्ड स्टेट. सो डेनियल सेल की सेल पोटेंशियल 1.1 वोल्ट है तो उसका इक्विलिब्रियम कांस्टेंट क्या होगा, देन वी कैन फाइंड बाय यूजिंग दिस इक्वेशन. अब when we are writing this equation then change in electron we have to find out, just we are knowing that change in electron for this reaction is 2. So सब पहचानते सब पता है, then just we have to put value in this equation. Standard cell potential is 1.1 volt. 0.0592 divided by 2 into log Kc. अब सिंप्लीफाई करेंगे 1.1 वोल्ट 0.0592. तो सिंप्लीफिकेशन इस तरह से भी लिख सकते हैं डायरेक्टली log Kc equal to 1.1 वोल्ट multiply 2 and divided by 0.0592. चलो इसका सिंप्लीफिकेशन लो तो उसका सिंप्लीफिकेशन आपको मिलेगा 37.288. अब इसका सिंपली एंटी लॉग ही लेना है तो एंटी लॉग ऑफ 37.22288. तो 0.28 का एंटी लॉग 8 में देखेंगे देन यू आर गेटिंग ए वैल्यू 2 और जो पॉइंट से पहले डिजिट है उसको पावर में रख देंगे देन 10 to the power 37. सो डेनियल सेल का इक्विलिब्रियम कांस्टेंट हमें मिला 2 into 10⁻37. सो किसी भी सेल के लिए यदि हमें सेल रिएक्शन पता है, स्टैंडर्ड पोटेंशियल हमें पता है, then what will be the value of equilibrium constant? This we can find out with help of Nernst equation.